step 1, you're going to write the equation. Now in this case, it's been done for you. You did not have to come up with the phases. You did not have to come up with what you're starting or ending with. This lab is looking at the oxidation of copper. So it goes from copper, solid form.
So the whole thing you're trying to do is just oxidize copper?
Yeah. Plus nitric acid in aqueous form. You're going to get copper nitrate, copper 2 nitrate. Aqueous form. Plus nitrogen 4 oxide gas, which is also called nitrogen dioxide, plus water, and we say water is in the liquid form. Now, I know that your lab balanced it for you already, but I'm going to leave the numbers off because we're going to work it all the way from the beginning, do the whole oxidation reduction thing. So in this lab, you're starting out with solid copper, and you're going to make it go through, I think 3 or 4 different reactions. And every reaction is going to need to turn it into a copper that has a charge. So copper in its solid form has no charge, and we need to get it into copper with a +2 charge in order to make it react. And then we're going to do a replacement reaction, I think, and then another replacement reaction, so that we can see copper with all these different in all these different ways. Okay, second step in anything involving a redox is you have to determine the oxidation numbers of every element in that equation.
So would it include polyatomics?
It will. Okay? The reason is because you've got to figure out what changes oxidation numbers. And so you're not going to know that unless you go through and find every single oxidation number. And when you get good at it, you can look and tell probably automatically, but right now we're not there yet, so we got to do every one. Okay, because this is in solid form, uncombined, it's a 0 charge. Now, this is our only source of nitrogen. But when we look over here, we've got 2 things that come from that. So that's going to be something that we have to keep in mind whenever we're pulling this all together. The hydrogen, this is your nitric acid. And if you'll remember, hydrogen has a +1 charge. The nitrate anion, NO3, has a -1 charge. That does not tell me what the charge of my nitrogen is. So I'm going to have to figure that out. So I'm going to pull this out and work on it. because I need to know what is the charge on the nitrogen and what is the charge on the oxygen there. So nitrate overall has a -1 charge. And I know that because of memorizing, right? When we did compounds or molecules, the overall charge is 0 for a compound or molecule, so you ended up having an equal 0 here. But this is not a compound or a molecule, it is an ion, a polyatomic ion. So its overall charge has to equal to -1. So every oxide is going to have -2. I've got 3 of them, so 3 times -2 makes this. Okay, now I don't know what the charge on that is, but I do know I've got 1 of them. So x minus 6 equals -1. This has to be a +5. I've got 1 times something. Okay, so this charge is a +5. Hydrogen ion, hydrogen cation is always going to be +1. That's a -2. Now, this copper right here, in case you're not seeing why it's a +2, I'm going to pull it out and I'm going to work that one out for you too. Because in order to name this, you have to know what oxidation number. So we've got CuNO3 2. Now the nitrate again has a -1 charge. In this case, we're not dealing with a this is a polyatomic ion, but it is bonded, so overall it is a compound. Because overall it is a compound, the overall charge is going to equal what? 0. Okay, so I know I've got 1 of these coppers. I've just got to figure out the charge on it. So I say 2 times -1 gives me a -2. So
that's got to be a +2.
+2. I've got 1.
So the charge is +2.
Okay, so this is copper 2 nitrate. So this has a +2. All right. I already determined that this charge on a nitrate, the nitrogen in a nitrate polyatomic ion was a +5, and this was a -2. Now, this nitrogen dioxide or nitrogen 4 oxide is in the gaseous form. That means that it is bubbling up, going out of our solution. It is not broken down into ions floating in our solution. So overall, this molecule is going to be equal to what charge? Remember, it is not it's not a polyatomic ion, it is a molecule.
Yeah, the nitrogen is going to be +4, but it should come out the overall.
Yeah, like overall, 0, because this is not a polyatomic ion. Okay, so do y'all see the difference? This is a molecule. This is the nitrate polyatomic ion.
Oh, okay.
This has an overall charge of 0. This has an overall charge of negative
So what's
1.
nitrite? Well, I thought that was nitrite, the NO2.
If it has NO2 negative 1, that's nitrite.
Okay.
Okay, but this is not this, because there's no charge up here.
So when you give you the formula, it'll give you that, when it's fitted. So it's polyatomic.
What now?
Like, how would we know if it was a polyatomic or not, if it has a negative with it?
Okay, if this were polyatomic, it would be in a formula. It would be like, this would be copper to nitrite.
Okay.
If it's by itself, then it's just a molecule.
So
Yeah.
the polyatomics are all in a formula. If you have a polyatomic, they'll be in a formula.
Yes. I think so. I think we're saying the same thing. Okay. So this overall charge is equal to 0. Every oxide in the whole world, negative 2. 2 times negative 2, negative 4. This is going to have to be what? I've got one of them, and so this is nitrogen with a +4 charge. Okay, so that's why it's called nitrogen 4 oxide. All right, water, it's in the liquid form. Overall, it's 0, but, I mean, remember, hydrogen has a +1, oxide would have a -2. So, we've done step 2. We've determined the oxidation numbers of every element. Remember, step 3 is we have to identify what is oxidized and what is reduced. So if I look, I've got one of these nitrogens that's going from a +5 to a +4.
That's reducing.
Reduced because it becomes less positive.
It's gaining.
Yeah. Do you understand? Okay. This one goes from a 0 to a +2, so that means it's what?
Oxidized.
That one's oxidized.
So that means it's losing electrons?
Yes, because it got
Yeah. Okay. So one way to remember this, if it doesn't come back to you or you're not recognizing it, there's this thing called mnemonic called oil rig. Oxidation is loss of electrons, reduction is gain of electrons. All right. Now, step 4 is we need to write the ionic equations and the reason for writing the ionic equations or the ionic equation is because we've got to know how to set up our half reactions. We need to know what goes with what when we write the half reactions. So that's why we're going to do this next step.
If we were to write out our reducing, it'd be the nitrogen plus 5 arrow, nitrogen plus 1.
That is being reduced. Okay. So the phases here are important in everything. We have copper in a solid phase plus nitric acid. Remember that our nitric acid is in the aqueous phase. That means that they're pulled apart by the water molecules. So in our bucket, we've got hydrogen ions floating freely, and we've got nitrate ions floating freely. And we look over here, we've got copper 2 nitrate in the aqueous form. That means that copper with a +2 charge is ionized. It's floating around freely. So we show that as being aqueous. And we've got 2 nitrates floating around in aqueous form. For every, because, does that make sense? Okay. All right. Now this right here, this nitrogen dioxide or nitrogen 4 oxide, that is left together because it's not floating in aqueous form. It's a gas, and any kind of gas is going to bubble out of your liquid. And then we've got water in the liquid form. So we just write it like that. Now, understand that the next step, we're writing down the species that are going through a change. So step 5, we're just going to start writing down the oxidation half reaction. So copper is going from this 0 charge here to the +2 charge here. So copper, solid form, goes to copper +2 charge, aqueous form. So this means copper is oxidized, and so because it is being oxidized, copper is known as the reducing agent. Because it causes something else to gain electrons. Now, Step 6 is that one that's going to be repeated for both half reactions, and it contains kind of 3 different sub-steps. We got to balance the elements, the number of atoms that are involved. Then, if there is an acidic solution, we balance the oxygens with water. In the case of our electrolysis solutions, balance with hydroxide. That's like, you remember last time we were here, whatever day it was, we had the basic electrode and I added the hydroxides in there. That's what I mean by that. And then finally is we have to balance charges using electrons. Okay, so when I look here at this, what now? Okay. So if I look here, I've got 1 copper and 1 copper. That's good. I have no oxygens attached, so I don't have to worry about the oxygens. All I have to worry about is the charge. Over here, this has a 0 charge. I've got 1 of them. So 1 times 0 gives me overall 0. I've got 1 of these times a +2 charge, gives me a +2 on this side. Now, the charges have to be equal, and the only way we can do that is by adding negative electrons. So if I add 2 negatives there, that will give me a 0 on this side. So I put 2 electrons.
I don't think I understand. Why wouldn't you do it to the neutral charge or to make it the same as the other one?
Because if I added 1, you'd have a negative 2. And this is a positive 2.
Okay, so you're making it +2 to 0 by adding it.
Right.
Okay.
So under the copper with the 2 charge, when you write that 1x in parentheses +2, it means you're adding 2 electrons, and since they're negative, that's making it a -2. Take 2 electrons
Yeah.
away. Or do you
Well, because
are you taking 2 away, or are you giving them 2 electrons?
I'd be,
You'd be taking 2 away.
yeah. Okay, numerically. These numbers have to equal out. They don't always have to equal to 0. You could end up getting a -6 over here and a +4 over here, but in this case, one of them 0 and one of them is a +2, right? So then the only option I have is adding these negative numbers, or these negative charged particles. So if I add negative to this side, I just keep getting negative. If I added 1 electron, I'd have a -1 charge. 2 electrons, -2 charge. But that's not going to help me, because this is, no matter how many negatives I add over here, it will not give me a positive right here. So if I add 2 negative electrons here, that's saying 2 times -1 charge gives me -2. Added to this 2 gives me an overall 0. Now both sides will have an overall 0 charge.
So I mean that copper solid now? This is storage, or is this? They don't change the form of it?
It's aqueous over here, but yeah, in the beginning it was just plain solid copper. So if I were to show you a piece of copper wire, it would look like this, copper, solid. But now if I change that into an ion, it's that blue, like that blue solution that we worked with. Okay. So this is my oxidation half reaction. Step 7 is that I have to write down my reduction half reaction. And I'm going to go ahead and write down step 8 is to repeat, this step 6, with the reduction half reaction. So I'm going to go ahead and get a clean piece of paper. Now, my reduction is this nitrate, the nitrogen that is in this nitrate is going to get reduced to this nitrogen 4 oxide or nitrogen dioxide. So I have nitrate with the -1 charge, aqueous, floating around in solution, and it is going to gaseous nitrogen 4 oxide. And remember, this overall has a 0 charge. So step 1, I've got to balance my nitrogens, and that works out because I've got 1 nitrogen here and 1 here. Step 2, I have to balance these oxygens. Now I know that this is in an acidic solution because I'm dealing with nitric acid. Okay, so if this is nitric acid, then I've got an acidic solution. So the way that I balance out these oxygens here is I've got 3 on this side and 2 on this side, is I'm going to add water. So if I add 1 water here, that gives me 3 oxygens on this side.
Right.
The problem now is that I've got 2 hydrogens.
You gotta add.
Now I can do this because these hydrogens are floating around in aqueous solution because this is an acid mixture, and they're there. So I'm not coming up with stuff. They are honestly floating around in solution there.
So Are we doing this because of the step? Because it's acidic?
Yes. Okay. So, 1 nitrogen, 3 oxygens, there's 2 and 3. I've got 2 hydrogens, 2 hydrogens. So now all my elements are balanced. I need to do the charges now. I have one of these times a -1 charge, which gives me a -1. I have 2 of these times a +1 charge, which gives me a +2.
That balances out to a +1.
Yes. -1 plus 2 is going to give me a +1 on this side,
So that's the overall
for that side.
side,
Now right here, because this is in gaseous form, it's 0 charge. I've got 1 times 0 gives me 0. This is in, liquid form when we add it. 0 charge. 1 times 0 is 0. So over here I have 0 charge.
So you have to add an electron on the left side.
Right. If I add 1 electron, that'd be 1 minus 1. That would give me a 0 over here. So I can just go ahead and add that. So this one is my reduction half reaction. That means that this nitrogen in my nitrate ion is reduced, and because this nitrogen is reduced, it is called the oxidizing agent because it causes something else to be oxidized. Okay, now the next step, step 9, is you may or may not have to multiply the half reactions so that the electrons are equal. Is that y'all? Y'all can give me 2 more minutes? Okay. Alright. So notice that in this half reaction, I've got 2 electrons, whereas in this half reaction, I've got 1 electron. So I'm going to multiply this whole thing right here by what number? 2. So when I do that, I get 2 electrons plus 2 nitrates aqueous.
Wait, why are you multiplying by 2 again?
Dude.
Got to have 2 electrons.
Okay, I get it.
Because if I have 2 gained, that means 2 are lost. Megan, was that a question or a stretch?
High school students, you're invited to come to the college classroom for a piece of cake during break today. We remind our students that went to New York City to please stop by the office for just a minute. And we also want to let you all know that during break today, you need to get anything off the top of the lockers. If you have stuff on top of the lockers, it needs to be taken down. At 4th period, Gabe will be taking all of those items and getting rid of them.
Okay. So all I did was multiply everything by 2. So I have 2, 2, 4, 2, and 2. Step 10 is I'm going to add the half reactions together. So I'm going to rewrite my oxidation half reaction, just so it's down here where I can see it. Alright, so for this one, notice that 2 electrons are going to cancel because I've got them on opposite sides of these arrows. So I've got 2 nitrates. Oh, yeah. Plus 4 hydrogens, plus 1 copper, giving me, yes, so all I've done is just added these together.
So it doesn't matter what order you put them back in, actually add them together.
Now, the final step, number 11, is that I'm going to reassemble my half reactions into the original equation. Okay, so number 11, I'm kind of reassembling So when I do that, sometimes this is where we get into having to play around with things a little bit. Our original equation was this right here. So I have only 1 in front of this copper, so I would leave 1 in front of that copper. Now, notice that I have 4 hydrogens here. I'm going to try putting a 4 in front of this nitric acid, and then I'm going to see if it all works out. If not, I'll have to go back and redo it. I had a 1 in front of this copper right here. I had a 2 in front of this nitrogen dioxide, and I had a 2 in front of that water. Now I'm going to go back and I'm going to double check everything, and if all of my elements don't equal on the same side, then I've got to figure out how to make them equal. But I got 1 copper, 1 copper, 4 hydrogens, 4 hydrogens, 4 nitrogens. I've got 2 nitrogens here and 2 here. That's 4 nitrogens. I've got a total of 12 oxygens on this side. So I've got 2 times 3 is 6 oxygens here, plus 4 oxygens here, that's 10, and 2 oxygens here is 12. So it's balanced. Now you go home and you rewrite this to where you understand it. And step 11. Have a good day.